As always, if you have any questions about what you are seeing on the screen, then ask them on the right-hand side, and then we can answer the questions as we go on. So what we are hoping to achieve by the end of this webinar series is this. It's a very complex mechanical, engineering, and electrical and plumbing system. But let's not start here. Let's start first with the electrical plan. As you said.
Yes.
So we are just going
in the same building. We will talk about that.
We are going to use the same building for all the demonstration purposes. So let me just fire up the plan where we are going to start. So lighting plan. Now, when you are creating a lighting plan, obviously you can do this with very simple lines.
Yeah.
Why would you use any other system?
Yeah, well, here, just as we will demonstrate, is one of the biggest differences that the software using this design system for the lighting plan, it is able to tell you whether you have kind of empty holes in the design, whether everything is connected or not, and it will be able to tell you whether some connectors or some switches have some free ways that you can connect to other parts like the lighting system or not. What you see actually on screen is when you select a switch with its 2D symbol, you can place all these switches using the symbols of the software. Those are the two symbols at the left hand side that you can see that represent the ways of the switch. So those are all free because, as you can see, those are green, and at the bottom of the screen now you can see the same. So whenever you see a green connector, a green way of that socket or switch, then you can connect it using the lighting plan tools here in the interior lighting design part. And then actually there's a bunch of commands here with the settings, or the switching between the symbolic and the regular view. We will go through all of these.
Let's stop here for a second. You said that the main benefit is that we can track how the plan looks like. Now let's demonstrate that. For instance, I can display the lamp statuses. Now this means that my current 5 lamps and my LED stripe, which is here, are green. That means that they are not connected to anything else. Similarly,
so status means whether it's connected or not.
That's right. Yes. Similarly, I can do the same thing with the switches. So I see that neither of my switches are connected. So
and green means free for the connectors and the
green means it's not connected, blue means it's not fully connected, so maybe one of the ways is not taken yet, and red is fully connected. But let's start with the beginning. So what we want to do first, we want to change this representation to something else.
Yeah, well, in this case you can use the second command, the first one with the settings, and here you can actually use the symbol libraries of the software. You can actually also create your own symbols if your country or your habits differ, using different symbols for all of these ceiling lights, floor lamps, spot lamps, and so on. And then you can also set up the line type that you would like to use for connecting those visually. And then when you say okay, then the software will actually it is able to switch between the symbolic and the real representation. Now what we see, it was the top view of these fixtures, and now what we see, it's a symbolic view exchanged because actually you can actually determine whenever you create a lamp in the software as it is fitted as a ceiling lamp, a wall lamp, or a pendant lamp or something like that. And based on that, which is actually at the left-hand side, based on that, the software with the lighting fixture that is the one. The lighting fixture determines how it will be treated. There is one setting; it's the onset, and when it is onset, it is treated as ceiling light. So the default, whenever you have an old object where you didn't set this up, it will be treated as a ceiling.
That's right. So let's start connecting the elements together. And the way it works is this: we select the switch itself and we click on the available ways. So if I do that, I click on draw and I can click on the element I want to hook up with the switch. So that's what I'm doing right now. And I connect it. But the show is not over yet because I can click on additional elements and I can connect additional things. Now, if I go back to the lighting plan and track the status of the lamps, I see that now these 3 lamps are connected. So that's good. And the 2 wall lamps are still green, so they are not connected yet. Switch statuses, I see that this one is taken. So this is all complete. That's good to go. Now let's see the other switch. If I click on it, I can connect to one of the ways. Let's connect to this one. Click draw, click on one of the wall lamps, and I click on the other one. And again, just to be sure, I'm going to go back to the switch status. I see that the switch is now blue. This means that one of the ways is now still not taken.
Yeah,
so
that's the green one over there. Yeah.
Let's say I'm going to hook this up to the LED strip over here. So I'm just going to click on the line, click on the LED strip, and I connect it. And I don't really enjoy the way this line looks like, so I can just go back and bend it a bit.
Yeah.
Again, you can change the line times, you can change the line color, but that's the starting point. And now the important thing is that the elements are connected together, so you can track what is taken and what is not taken.
Okay, so now if I would check the statuses, everything would be
yes. Let's do just that. So
occupied,
switch
right?
status, both are taken.
Yeah.
Lamps are also taken.
Okay.
That's one way to do this, but there's another very smart tool in here, which is the room built-in power. Now, this works together with the room and area stem that we have over here, the living room.
Okay, so first I have to. Can you remind me where I can find this tool?
You can do that in building, room and area.
Okay.
And you have two choices. You either recognize the room counter or you sketch your own room.
Okay, so both works.
Yeah,
okay,
both
great.
Works. In fact, we can do it just now. So I'm just going to delete this, and I'm just going to make another one like that.
Bless it. Yeah.
Yes, it's going to be a living room again.
Okay.
So what I do, I go back to interior, lighting plan, room built-in power, and I'm just selecting the room and area stem. Yeah, that's right. And now this window comes up, but since you're the architect, maybe you can explain a bit further what we see over here.
Well, all those come from sort of standard that you can select from, and the software then makes calculations based off these things here. Whether you select the environmental factor to be the first or the second one, the illumination type, which really determines how bright lit this building part should be, or you can actually, well, let's just change it to something like community spaces or something like that. And you can also change this lighting efficiency, which is actually coming from a kind of standard book that you can find. But if you don't know which one you should select, you will find this information online, and you can easily select what sort of lighting system you are using actually here. Well, we are using mainly direct lighting here. There's only a little bit of dim lighting in the corner. So this actually already tells us how much of the luminous efficiency.
So that's what we have to achieve, or that's what we already have.
Well, this is what when you consider the gross area, and using these things, the software calculates this value based on that, and then you can actually tell that what sort of generic light source types you use in this room. Like, let's say we are using LED modern light sources, and then the software tells us if everything here is LED, and if the room matches these criteria, then when you say OK and you place it, it will tell you a kind of generic information of what it should be in case of the wattage that occupies this space. This is not a kind of a mandatory or something like that you have to stick to. It is just giving you an overall information how much of the lights are brightening up the scene. I mean, this specific room, based on those things that you have placed over there. Okay.
That's right. So basically, this tool, the lighting plan, works together with the room stem. That's all we need to.
Today we are talking about all these things that help you designing electrical and MEP design, and also the floor heating system. These are all conceptual design. This is not what we are talking about. This is not a full mechanical design system where the software will actually measure and evaluate the systems and tell you calculations based off those. These are for the architects, what we talk about, and for the architects and the interior designers to be able to represent these systems and give generic information about those systems.
Now, that being said, let's move on to the next topic, which is about creating MEP systems. And just for the illustration, this is what we are hoping to achieve. So that is basically a very simple heat exchanging system in a house. That's a similar example that we are going to do. So we are going to need some fittings, for instance, a heat exchanger unit, which is going to bring in fresh air, distribute it in the building, and extracts the stale air and exhausts it to the outside. So that's the system that we are going to build up, and for that we have a project that we are going to work on. It's actually the same project that we have been working on. So let me just fire it up and explain you the basics. So like Yildiz mentioned, this is a conceptual design. So this is for showing how the system should look like. So that's what we are doing now. So
now we are working on a floor which is above where we had been previously, and this is close to the roof. So when we place a heat exchanger, we will be able to directly extract the air out through the roof. But any sort of other solution will absolutely work. But before we start, just as you highlighted now on screen, we will create at least a suspended ceiling or something that holds this whole system, or at least covers this part of the design. And again, here what we do now, we consulted with the MEP designer, and we are not designing the system, we are only replicating what he calculated in a software which is able to calculate these systems. And for our architectural purposes, we visualize them because of how it looks like from inside, and because it makes changes how we create the structure of the ceiling first things first, and other parts of the design. So this is the purpose. So now we have all the suspended ceiling. It's a plain ceiling everywhere. So now what we need is to place this first, perhaps the heat exchanger.
Yes.
That is the main unit for this system now.
I'm going to look for one. Meanwhile, can you explain to us how these items get to the software? So
okay.
Where do we get this information from?
Yes. Well, now what we have here, it is something that we have already downloaded and use it in our design. But all these things you can find on, for example, the bimobject.com. And those items are all coming with the information of where the used air is going out, where it's all this information that you can see on screen. Number 1, 2, 3, 4, 5. Those are all numbers that we didn't add to this object, but we simply downloaded from the bimobject.com, and all those information, the in and out connectors of this unit were already there.
I'm just going to move that bit here so I can fit. One problem with this element is that it's not on the right height. We can see it, so that's because the base
it should appear above the ceiling somewhere.
That's because the base elevation is not good enough. But if I click on the elements, now you can see it in the 3D appearing very nicely.
Yeah, that's right.
It has numbered ports. Now let me illustrate how this works. I showed you before that if I go to info and I pop up the information of this element, I see that it has certain ins and outputs. And these are the ports to which and from which I can draw my pipes.
So there's supply air, exhaust air, return air, supply air for the HVAC system in and out.
Yes, but let me show you an example. For instance, I want to bring in the fresh air somehow, and I'm going to do it from the 5th port over here.
Yeah.
All I have to do, I click on the node and I go with draw. And what happens is that the software, with the diameter which is available to it, is going to draw a pipe. I can do it visually, or I can just type in the value. I'm just going to say this is 800 millimeters
or so.
Or so. Hit enter, and it appears. That's right. You see it appearing right there. Now there's another pipe I want to make here, and now it's going to go up
for exhausting the used air. Yeah.
So that goes like this. I click on the 3rd node, click draw to some extent. Over here. And I'm just going to go vertical, 1,200 millimeters, for instance. Hit enter, and I see that the very basic.
I need to finish
it. A very basic system is already taking shape. So
the brilliant thing is that the software is already adding the all the joints and or bending the unit properly. So you don't have to kind of find the object in a library, what is the proper cross section, and fit them together, but the software automatically finds it. We actually have a built-in MEP connector library in the software. We will talk about that a little bit later. But all those things are automatically coming with the design. When you design the duct system, the piping and so on, those are all coming automatically into place when you need them. And we will also show you how to add specific connectors like cross connectors or T connectors or something like that.
That's right. Next task is I'm going to have a duct over here and some vents I want to connect to.
Yep.
So let's start with the vents because we already talked about some elements. So I'm just going to...
That is for bringing in the air or
that's
sucking
for
out the air?
bringing in the fresh one. So I'm just going to go with this terminal diffuser, which is similar to the heat exchanger unit because it's going to have one port. First, I'm just positioning it roughly, and then I can just rotate it. And even though I'm not an HVAC professional, so you know, forgive me if that's not accurate.
Yeah, me too.
I'm just going to position a few of these elements
yeah.
close to the windows. So I'm just going to have one here. I'm just.
So then you just move a copy. But actually, is the height okay?
I don't think so. I don't think so because I don't see it in the 3D.
No, it's not.
You're right, but luckily I have the data necessary, so it's going to be 2,490.
Yeah, that's better.
Good.
Yeah,
thanks.
Because the ceiling is somewhere 250 or so.
That's right. That's right. Yeah. So I'm just going to move a copy, let's say from here, and I'm going to have one unit over here. And I think another would be in order somewhere there.
Yeah, there's a third window on the same side.
I could have, actually now this reminds me, I could have used some mapping lines or grids to position that. It's up to you how you do it.
Yeah, and as this is actually a symmetrical building, you can all kind of mirror those things as
and
a copy.
That's what I'm doing right now. I want to have 3 units here, so I'm just going to go to Edit, Duplicate, Mirror, and let's find an axis with which I can...
It's somewhere in the center.
Yeah, I hold the shift so I can find the vertical plane, and there we go.
Yep.
So now I have the 6 vent diffuser units.
Yep, okay.
How do we connect these 6 up to this unit? I need to have a duct, and for that I go back to MEP, go with duct, rectangular duct, and I'm just going to draw a U shape like this, an upside down U shape. I'm going to start from here, go all the way here. I have a printed out version just to make sure.
Yeah, yeah.
And I'm just going to do it.
Make sure you have enough space because we need all those band
that's right.
parts.
I think this is good. So I'm just going to
It's kind of symmetrical.
Okay, the duct is not showing up. Why is that? Because the base elevation is not
I think we have forgotten setting up the...
Yes, I could have done it beforehand actually, so I'm just going to do it now. 2,800. Now I see that my system is taking shape, but the problem remains, how do I hook up things?
And if you align the view to see that actually those are on a different level, so that's also a problem. That the rectangular tube or duct, what we have here, is on a different level as the
it's a problem here too. So it's not
and also there. So we somehow will need to find the proper place.
It's difficult to do it manually. So for that we have some automated ways to do it. But let me just.
But first we need some sort of connectors that kind of connects like a wall connects to another.
The fittings is what we are looking for, and we need to have a rectangular T. And what I need to do, I'm sorry, I have to go back to. You can do this in the 3D as well, but since I'm working on with the details, data that I can type in, I prefer the 2D. So I'm just going to.
Actually, we have the MEP designer's plan here, so we are replicating what we saw over there.
So I'm positioning the T, but I'm not, I didn't manage to align it. So I'm just going to select it and move along path and align it.
So you can nicely align it with that.
But
it's only horizontal alignment. We still have a gap between the two things in a level. Yeah.
Before I figure that one out, I'm just going to make a few copies and align them with the 3 events over here. Yeah. I'm not going to do it on the other side because that's just repetition. Actually, one thing that reminds me, I have to cap this off because
it's an open end.
That's the end of the system. I'm just going to do it in the 3D. Click on it. I'm going to cap the end over here.
And the same thing.
And I just click here, just to make sure that I'm not forgetting.
So it's nice airtight system.
That's right. That's right. Now, what comes next? I have to connect the T with this unit, and I do it from the T itself.
And actually, there is one another issue with this here, which we will solve, obviously, that the cross sections are different. Here we have a rectangular tube duct, but there the exhauster, the heat exchanger, has a circular intake. So we have to somehow
not only
convert.
For that, but the diameter is different as well. So all kinds of mess you can imagine.
But it is all solved. So you will see how to solve this sort of system.
I click on the node on the T, and I go with the draw with square round transition.
So first we convert the shape to another one. Yeah.
I can choose from a list of diameters. I know it's 100 millimeters. It's just faster to type it in at this point, and I'm just going to draw it all the way here. And now I need to bridge this gap somehow, but you see on the 3D that it's different heights. So I'm just going to go with add flexible and over here we just did it. So I now have a flexible tube which connects the two elements together.
And it's all automatically calculated. We didn't have to select the transition part. We didn't have to select the connector and how it was connected. It is all automatically calculated.
Not needed, but I'm going to show you a bit more difficult scenario when I want to make a larger change in diameter. I do it like this. I click on the port again, draw with a square round transition, and this is going to be 160 millimeters. So it's a larger one. Yeah, it's a bit larger. You see that there's a minimum amount that I have to draw. I cannot make this shorter. So
that's for the transition part.
That's right. Yeah. There's a minimum amount that has to be drawn because otherwise it's not going to work. I'm going to add the flexible again and click on the tube again.
Right. So, and actually this is what we repeat for the rest of the
that's right. I'm just going to do it again, just select. I'm going to do it only 3 times, and after that I'm going to rely on another stage of this project that I have already created. There you go. And there's a third one. I just highlight 160. Again, I could pick this from the list as well, but I'm just going to type it in. And here we go. Okay, so now I have the 3 ports hooked up, and I'm just going to load up another stage of this project when I already have all 6 of them. I don't want to bore you with doing all these things all the time, so I'm just going to go with one where I actually have.
Well, no worries. So what we need is, when we create such a system, is to create the duct main system, the main path, and then setting up these tiny parts that we connect together, and when it's necessary we can bridge the gap between in level and using the reducers or the shape changers that the transitional parts, and those are all automatically calculated. That's the best part of this thing, that these are all automatically transitioned and connected together. We didn't calculate what the size is. The MEP designer did. We are just replicating.
And we don't care about the airspeed as well. We don't care about the moving parts. So we just want to represent what we have on this on this model. So next task, actually 2 things I want to show. One is a circular vent. So how we add a circular duct.
That is actually taking out the use there.
Right? And another thing is what happens if we don't want to connect things with a flexible connection, but still we want to figure out the level detail problems. So how do we hook up things which are on a different level? But I cannot use.
So when we only have solid parts that we need to use. Okay.
Yes. For whatever reason, I'm not allowed to use flexible parts. I need to do it vertically and horizontally. Let's see how that happens. But first, I have to add the vents on my floor plan. So I'm just going to go here, and I'm going to now position the parts which are going to extract the stale air. It's called the exhaust fan. And actually I have a cheat sheet about where to position it, but again, I'm not...
It's like roughly, And we forgot to set up the height, so it was around 2,800 something, or
2490.
Because it's the same level as
because
the other one.
And I see that it nicely goes into the suspended ceiling, so that's perfect.
That's right.
That's just the best. So I'm just going to
a few copies.
Make one copy over here. So I'm just going to copy from the midpoint. Again, I could be more accurate than that, but at this point this is pretty conceptual, so not needed. I'm going to have one here and one there, just to show you what happens if things are not really aligning. So I'm just going to make a copy from here and position it over there.
I need to flip it over.
Yeah, I need to...
Actually, there is the rotate 180 degrees, which just does the job.
Makes things easier. And the base elevation is good as far as I know, so that shouldn't be a problem anymore. So I have my vents, but again, how do I connect them to the main unit?
And now we actually need to use a different system, different piping actually, which is not with the same rectangular duct, but we use a round shape.
So this is going to look like
drawing
this.
It looks the same.
It's not different at all. One thing what I have to figure out once I have drawn it is its base elevation, because again this is going to be on a different height than my other ductwork. So I'm just going to do it like this. Again, before I forget, I'm going to cap it off. This time I'm going to do it in the 2D. So cap one end, and I'm going to cap the other one. So this is good. And again, let's figure out the base elevation, which should be, just a second, it's going to be 3076, and if I do that, I see my system is taking shape pretty nicely. So I see that
Yeah,
things are
it's not
colliding.
conflicting with any other thing.
Looks good.
Looks okay.
Good. Looks good. Okay, first thing I have to do, I need to connect this round sectioned part with the unit's port, this one. So let's see.
We add some sort of T connection.
Yes, the air comes in here and it goes out there. So this is where I want to connect. So I'm just going to go to fittings, add the
T
round T. That's right. It should be somewhere here. And I'm just going to start drawing from here. Okay,
do we need to make copies of these to be able to connect
that makes sense. That makes sense. Thank you very much for bringing this to my attention. So I'm just going to move a copy.
Because now we can nicely align with
that's right. So I don't have to do it too many times. So I'm just going to... I like how it snaps to the port and not to the object.
Now there's the problem with this because we cannot really align with that.
So I cannot do it like that. So I'm just going to leave it like here.
Okay.
Okay.
We will figure it out,
one thing I want to show you now is what happens if you want to connect two elements, but you don't really know where and how to draw it. Here's what I'm going to do. I'm going to start drawing this element up until to this point over here. And then I'm just going to use the auto connection and click on the port where I want to connect to. And if I do that, the software does the job by itself. So it's just going to connect the elements.
I see.
So the connection is solved, and if there were any kind of wall in the way, then it would just go around it.
So it is kind of like an auto routing system.
Yes.
It is finding its way through the structure.
That's right.
And I think this is very, very powerful because sometimes you just really don't know how you can connect them, and the software is actually just figuring out the best way. Now the point here is that you should only draw the part that you are sure that you would like to drive in a certain way, in a certain path, and then you can leave the rest of the software. It will actually find the best path through that.
That's right. And I'm going to use the same method to connect this T with this element. But again, the problem is that these guys are on a different level.
Yes.
So I need to bridge that gap somehow, and I'm going to go back to the 2D to do that. Things start out manually. So I click on the port and I start drawing, and by hitting the shift key I can tell the software that I want to draw it until this point. And I'm going to go a little bit closer here, and then I'm going to use the auto connection or auto routing to click on the element, and then the connection is solved by itself. So
now without the flex.
That's right. That's right. So this is a very rigid horizontal and vertical connection, and then these elements are connected together. I'm just going to do two more examples here and one there. You get the idea. It's doesn't have to be over explained. So I'm just going to draw the tube, let's say, until to this point, and add connection, and there you go.
Perfect. Yeah.
So that's how you do it. And in fact, let me load up the final version, and that way we can show you what happens once you have the whole system set up. Because there's a few things you can still do with this. We mentioned that this is conceptual, but that's not entirely true because there is some data that you can gather from this.
Yes.
One thing is, but let's start with the visual layout, because you can isolate the parts. So you can say that I only want to know, or first I want to know primarily the MEP parts, or I want to know the MEP parts only. So if you want to create like a drawing out of this, screenshot or etc., whatever else, then you can do it this way.
This is actually a visual filter. So we didn't rebuild the 3D to get only this data.
Yes.
We are actually using that filter, the MEP architectural visual filter, to filter between the items that are considered as architectural parts, or we can actually just disable the visualization of the MEP parts, and we can combine them. So this sort of visualization helps when you have a complex model with a very complex MEP fitting, MEP designed tube or duct system wherever you have created it or you imported it somehow. In that case, the software will visualize it this way. You can actually have this multi-story building fully visualized with all the floors, and then combining that with the MEP primary, which means that primarily we are interested in the MEP parts, so the software will highlight those parts, just as it did before. We will be able to focus on the details just as they appear in this design perfectly.
And another thing what you can get in terms of information out of this system is, you mentioned that we are working with manufactured items. So these are real life, real world products.
That's right.
how do you get information out of these elements? Let's say I want to use tags on the heat exchanger because I want to know exactly its data. How do we do that?
Well, you can actually add tags to any sort of parts of the design. Now, what we have here, it's this part having all the piping and the ducts and so on. And when you would like to extract an information, you only need to go to the documentation and use the tags. And well, you can prepare tags. You can actually build up new tags. You can say that, okay, I'm interested in MEP design elements and perhaps MEP objects or the piping itself. We will actually talk about that because for the floor heating we need the length of the piping system. And then when we use the MEP object part here, let's say I'm interested in the object name, obviously, because I would like to know what that was. Let's just add it here. And what was the other one? We actually calculated or collected another sort of information, which was the height, perhaps, or the
connector elements.
Connector elements. Yes, that's right.
What kind of ports it has?
Yes. So we actually set that up and say, okay, this is what we want to list. We can add any more other information, but that's enough for now. And then we can use this tag and place one tag when we would like to select one item. Just before I do that, I just make sure that I have the text properties properly set. Since if it's not too large, as it is now, it's 100 millimeters, so that's actually, I think it's fine. I will just use that and go back to the the documentation and place one tag, and then I select my previously designed tag, which was the MEP object tag, and I say, okay, let's just place it and use this item and list everything that you can, that I actually added as an information. Just move it over here.
Just to keep it clear, can we connect the two together? Just using something that we have learned already in another lesson.
Yeah,
how do we connect the two elements?
It actually has something what we call a pointer line, and when you can just say that, okay, those two are connected. You can actually design it already with that leader or pointer line, because we have that command there. And just that now the point here is that whenever you move it, it will automatically follow that tag with this little leader. So what we can see here is that we have these connectors and what sort of connectors with what sort of diameter we have here and how they're connected. So that information comes automatically listed, and this is also part of the design, part of the documentation. So whenever we place it on a plot layout and we would like to publish it as a PDF or anything else, this is already part of that.
Yes, and the last example, which is a pretty similar thing that what we have discussed right now, is the underfloor heating, which is connected to MEP elements. Let me just load up the final version of this project where we're going to work on that too. Now, about underfloor heating, that's again, the problem is that we don't really want to manually draw these things. We want the software to use some kind of algorithm to sort of draw this on our behalf.
Yeah, and it's not necessarily because it's complex, but it's because it is kind of tedious to design all of those tubes, which are all parallel mostly with each other. So it would be much easier to tell the software, okay, this room has a floor heating system, which actually the software does. So when you go to MEP and you use the pipe part, and you use the pipe and then the underfloor heating command, then actually, as you can see over there, the software allows you to kind of draw the contour of the room. It is similar to when you create the polygonal room stamp.
Yes.
But now it's not necessarily connected to one room, so you need to find the contour where you would like to place this. So you can just click and say, okay, this is the contour, and this is a simple rectangular part. And then you need to set where this piping steps into the room. Now it's mostly through real openings like doors in between the different rooms. So I will just tell the software it enters from here. And when I do that, the software allows me to set up, or at least control the values that the software already has here. So the first things for the pipe diameter, the distance between the incoming and outgoing tubes, the pipes. And this is actually important, not only because of how easy the system will be to use, but also if this gap is too large, you will be able to feel it with your legs or the feet that actually one part is colder than the other. So you need to kind of place them not too far from each other, because otherwise the system won't work. The base elevation, this is where the piping will lie. So whenever you have a system, it's really based on your country's or the technology that you use, but usually it is around this level in most of the cases. So you can just lie it on a concrete pad, and then add the other layers of the floor system that you actually cover this flooring piping with. So this is correct. And what we use as another value is the distance from wall line. So you can actually take a little gap between the walls, and
so you can offset it from the wall.
And in some cases you can just keep it larger if it's necessary. So okay, this is what we have here, and let's say okay, so now the software automatically calculated the tubes, and what we see here is that if I'm actually on the ground floor, so let me just rebuild the building, and I would like to focus on this floor only now.
Yes.
And let's say okay. So what we get,
I think it's in the slab. That's why
that's right. That's right. And we cannot see that because we are not having this MEP MEP primary. But now that I can clearly see through the system, through all the solid surfaces, that it is actually inside the floor. So well, let's say I'm happy with this. In that case, I keep it. And the whole point here is that I didn't have to manually draw this whole thing here. But when I want, I can, let me just move this a little bit to the side. So when I want, I can actually add a little bit more. The software is trying to kind of find an optimal way to fill it as much as it's possible. But when you want, you can just actually move this node, make it a little bit longer, or actually add the new line to this one and kind of bend it, saying that, well, actually the density here is a little bit different, that's fine for this little area, but I just would like to add this new part, and then I'm actually finished with this one.
Perfect.
So now the warm water comes in, makes a turn, and it goes out from the room, and this you can connect with the other MEP systems as well. So now an important information that we need to have out of this piping is the length of it. And so for that, I think we can use the tags here, right?
I think so. We should, because then we want to know the length of these elements.
So in documentation, I just first go to create a tag, because I did not do that before, and I go to MEP pipe. Well, I actually already have a pipe tag here, so I only need to disable things that I don't need. Now I don't need the ID, the floor, the width and height of the tube itself, and the profile. What I need is actually only the length now. I'm fine with the length. That's okay. Let's say that's it. And then place one tag for this one, and this will be the MEP design pipe and pipe tag. See, now that's the only one is selected here. Let's just select that, hop that over there, and there it goes. I have to forget. I've forgotten to change the text height.
Yes.
But other than that, the software now tells me that it is around like 50 or 60 meters long, and for that size of the room, it's quite enough. But based on the rules that you used to do, this will give you a generic idea of the rough amount of pipes that you need to use for this floor heating system inside this room.
Perfect. That's actually what we wanted to show you about the MEP parts in ARCHLine.XP. And that being said, let's look at the questions, because we have a few actually. And what I see from the comments, that the viewers are very amazed at the MEP parts. There are two questions we can talk about.
Thank you.
What about cable tray for electrical systems? That's a feature that we have considered, and currently it's not available.
It is not supported at the moment.
It's not supported at the moment. Let's see what the future will bring. Next question, how about the support system that is steel hangers and the HVAC air volume calculations? Now, with the second part of the question, it's very important that we don't do calculations, and this is a conceptual design, so we want to represent the system. So even though these things are not supported at the moment, it's very unlikely that we are going to go into that direction, because there are dedicated software packages for that. So,
and the whole point is that we are a BIM software for architecture, architectural design and interior designs. So what we would like to offer here is the ability to the architects and the interior designers to represent these systems, not to design them, because that's a different profession.
That's right. It's all about the representation. And again, these features are available in ARCHLine.XP 2020. So stay tuned. In the next weeks, we are going to have even more interesting broadcasts about new features, new things coming up.
And soon you will be able to get your hands on the new version. It will be released very soon.
I think that's what they are mostly waiting for.
Yeah,
so, I would like to thank you for your attention and see you next time with some more interesting topics.
See you and thank you for the questions. Goodbye.
Bye-bye.